function calls to make target array. So we are giving an integer array nums, and we are also have this kind of a function. And for our array, so it is the length. So for example, this length is 2, and we are also giving this array the length is equal to the same length as nums, so it's going to be 2. And from the beginning, all the values inside of the array is going to be 0 and 0 initially, and then we can use this kind of a modify function to do operations for this array. So finally, we just need to check what is going to be the minimum number of steps to make nums to this array. Yeah, so instead of making the nums to the array, it's going to be a little bit difficult. So for example, if we have something like 1, 5, we will do such kind of operations. So first of all, it's going to become 0, 0 to 0, 1, and then 0, 1 to 0, 2, and 0, 4. This means we're going to do the second operation. Yeah, it means it's going to times 2. So here's the 2 operations, so here's 1 operation. And now we're going to increase 1, both elements, so it's going to be 2 operations. So finally, it's going to be 5 operations. As you can see, this is going to be really difficult. So how should we know we're going to do it like that? So this is only 1, 5. So what if there's 1,000 numbers inside nums? What if there's 10,000 numbers inside nums? How can we do such kind of operation? It's going to be really difficult. Basically, yeah, it's going to be really hard for us to solve directly like this. So instead of solving it directly, looking forward, we're going to looking backward. So what if we just prepare our nums? So instead of making 0, 0 to the nums, we're going to make the nums to 0, 0. So this is going to make the problem a little bit, yeah, easy for us to solve. So what is the example? I can't say it. Oh, so it is 1, 5. So let's just use maybe 1, 5. So if we use 1, 5, what's going to happen for us is that we can directly choose the operation 1 or operation 2, because for 1, 5, the values are odd. 1 is odd, 5 is odd. Definitely we cannot do the second operation. If we want to do it, we're going to divide it by 2. Otherwise, we're going to reduce by 1, because here is a plus 1, and then if we do the reverse operation, it's going to be minus 1. Here is a times 2. If we do the reverse operation, it's going to be divided by 2. So for 1, 5, we have to minus 1, so it's going to become 0, 4. So this is a 1 operation. And now we're going to continue, as all the values are even. According to the greedy idea, we always do the division. So this is actually the greedy idea. If there's an odd, definitely we cannot do the division. We have to do the reduce operation, minus 1. Now we have the odd. We have the even values. What are we going to do? Yeah, so this is a reduced by 1, 1 reduced by 1, 5 reduced by 1. Actually, there are 2 operations. Now, we're going to divide it by 2. It's going to become 0, 2. We consumed 1 operation. And now we're going to reduce by 2. It's going to become 0, 1. Yeah, it is another 1 operation. And we still have a 1, so it's going to be minus 1, because 1 cannot divided by 1, so we're going to minus 1, so it's going to become 0 and 0. This is the last operation. So in total, it's going to be 5 operations. As we can see, we already solved the problem. Yeah, even though here is a 2, it can reduce by 1 and reduce by 1, but we don't need to do that. According to the greedy idea, we're going to divide it by 2 and then reduce by 1, because this is the greedy way to solve the problem. Yeah. Now, let's analyze the time complexity before coding, because you might think this array is 10 to the power of 5, we might have time limit exceeded. Actually, it is not like that, because for such kind of operation, it always have a division of 2. Yeah, because if we use the 2 operations, at least inside 2 operations, at least we're going to have a division. So this means the time complexity is going to be log. Basically, it's going to be n log n time. That is why it works. Because for such kind of operation, it is minus and division. And the number of divisions is going to be more than and equal to number of the minus. So this means number of the subtraction. So basically this means it is a log n time. We can say it as a log n time, yeah. Or you can say, yeah, we just use a log n time. So the time complexity is going to be n log n. That is why it works. How can we solve it? We just prepare an operation. It's going to be 0. Now we're going to check while the sum of the nums not equal to 0. What are we going to do? We're going to prepare a counter from the beginning, because we need to count all the operations. Yeah. So let's just use O. If O modulo 2, let's say equal to 0 for n inside the nums. So this means all the numbers inside the nums are even. So if it is even, we can just prepare our nums. Yeah. So the nums is gonna be equal to n divided by 2 for n inside the nums. But we need to update the operation. How many operations? And we need a counter. So we're gonna count it from here. So count gonna be sum with 1. Yeah, the operation, the count gonna be plus equal to 1, because this is just a division. So otherwise, if there's only one or many, we don't know. At least there's gonna be at least one number inside of the nums which is gonna be odd. So if it is odd, definitely, yeah, we're gonna update the nums. So the nums gonna equal to n minus 1 if n modulo 2 else. So if it is odd, n modulo 2 means it is odd, it's gonna be n minus 1. Otherwise, it's gonna be, we're gonna keep it. Yeah, we don't need to do the operation if it is even. Only we do the operation with the number which is odd. So for n inside the nums. But before we do that, let's just update the counter. We just need to check how many numbers which is odd. So sum 1 for n in nums if n is odd. Yeah. Finally, we need to update the operation. So plus equal to the count, and then we just need to return how many operations. Now let me just run it. As you can see, it works. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases, and I think the speed is okay. Basically, we passed for all testing cases. And here, for all those kind of operations like the count, nums, and all, so this is just yeah, so this is just O(n) time from here. And here, how many checks? It is a log n checks. So the time complexity gonna be n log n. I think that's all about it. Thanks for watching. See you next time.